Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vector and parametric equations for line in R2. So as per the problem, for the line L, R equals 1 comma negative 5 plus S parentheses 3 comma 5 and S can be any real number, determine the following. So let's start with part A. So we have to determine an equation for the line perpendicular to the given line L passing through point P. The first step is to write the general equation of a line in vector form. In this equation, R represents the position vector of an unknown point that lies on the line. R naught is the position vector of a known point that lies on the line. T is a parameter and it can be any real number, and M is the direction vector of line. Now in order for a line to be perpendicular to another line, their direction vectors should be perpendicular to each other. This is a very important concept we need to understand and memorize. Now for the given line L, the direction vector is the given line L will be perpendicular to the line we want to find in part A if their direction vectors are perpendicular to each other. That means the dot product of the direction vectors should be equal to 0. Let's assume the direction vector for the line we want to find in part A is a non-zero vector A comma B. So the dot product of these two vectors should be equal to 0. So this is the equation we have to solve to find the value of A and B. So we can do the dot product on the left side. So we should multiply the x and y components. A times 3 is 3a and 5 times b is 5b. So this is the equation we have to solve to find the value of A and B. There are many possible values of A and B that satisfy this equation. The easiest possible values for A and B are A equals negative 5 and B equals 3. So we switch the components of the direction vector of the given line L and we switch the sign on one of the components. So for this case, I change the sign on 5. We could have also done it for 3. So there are many possible values for A and B. Therefore, the direction vector for the line in part A is negative 5 comma 3. Now we can write the equation of the line in vector form. As per part A, the line passes through point P, so we can use this point for the direction vector R naught. So this should be the final answer for part A. Now we can do part B. The point at which the line in part A intersects the y-axis. So we have to find the point at which the line we found in part A intersects the y-axis. So let's start by writing the equation of the line. We should change this vector equation into parametric equations to find the point of intersection with the y-axis, we should multiply the vector -5, 3 by the parameter t. So we multiply both components by t. Now we can add the vectors on the right side. So we should add their x and y components. And 0 plus 3t is just 3t. Let's assume position vector r is for point xy on the line these two vectors will be equal to each other if their x and y components are equal to each other. So we can use that to write the parametric equations. At the intersection point with the y-axis, the x-coordinate of the point will be equal to 0. So in the x equation, we should sub in x as 0 and solve for t. So we can add 5t to both sides. Now we can divide both sides by 5. So I get t equals 2 over 5. Now we can sub in this t value in the y equation to find the y coordinate of the point of intersection with the y-axis. So I get 6 over 5. So that means the point of intersection with the y-axis is 0, 6 over 5. So this should be the final answer for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.